All right, let's get started with the quiz review, the type of questions that are on here and that are on your homework will be on your quiz next week or in, this week, the following week. And so let's get started. I hope everyone's having a good day despite the rainy weather if you're watching this on Saturday. All right, so question number one, exponential growth. A population of 500 bacteria triples every hour starting at noon. Find the population after 4:20 p.m. All right, so let's decode this for a little bit. So how much are we starting with? So our initial value here will be A equals 500, right? And then what is our growth rate, right? Triples every hour, so that's important, right? So our growth rate R will be 3, triples every hour. Now, when do I start counting, right? When do they start multiplying, right? There's 500. When do they start multiplying, right? They start multiplying at noon, which is 12, right? 12 p.m. And they want us to find the population at 4:20 p.m., right? So the difference between from 12 to 4:20, that's 4 hours, 20 minutes, right? So it's 4 hours, 20 minutes. Now, what is that as a number, right? As a decimal that we can use, right? To multiply, right? That's our t. That's how much time has elapsed, right? So let's break this down. So 4 hours, right? That's 4, right? What about 20? How much is 20 minutes out of an hour? So let's find out, right? So 20 divided by 60 equals 1 over 3. So I have 4 and 1/3 of an hour after 4:20, right? p.m. So I could simplify this as my t will be 4.33 repeating, right? That's 1/3 as a decimal. So 4.33, 4 1/3 hours has elapsed after the population started growing. So let's put it in the let's work it out, right? So we're gonna get 500. That's our initial value. 3 multiplied by 3. How many times does this happen, right? This is to the power 4.333. So let's check that out in the calculator for our final answer. All right. All right, so 500 parentheses 3 to the power 4.333 repeating. All right. All right, so I'm gonna get 58,411. There's no eighth oven bacteria, so I'm gonna have 58,000, right? 58,411 bacteria. All right. So that is my final answer. All right. Let's take a look at my second question. Give me a second. All right. All right. So let's take a look at my second question. Let's simplify this radical expression, right? All right. The square root of 72 x to the 5 y to the 6. So let's break this down. Square root is, to the power 1/2. And what are we looking for, right? Square root, we're dealing with groups of 2's, right? Cube roots, we're looking for groups of 3 under the radical. And so let's break this down. So 72 x to the 5 y to the 6. All right, first thing we want to do, we want to break up the number, right? So let's divide by 2 here. I'm going to get 2 times 36 x to the 5 y to the 6. All right, so I could break down this 36 again, divide by 2, but we're looking at the square root. What's the square root of 36? If you guess 6, you're right. So you're going to get 6 here, right? So this is going to cancel out, right? This comes out of the square root. So we'll have to 2 x to the 5 y to the 6. All right, now what's going to happen, right? This 2, I can't break it down any further, so I know it's going to stay in, right? Now I want to break up x to the 5, y to the 6, right? So you can think about it like this, right? How many times does 2 go into 5, right? How many times does 2 go into 5? Well, 2 goes into 5 twice, and there's 1 remaining. So I could break it up at x to the 5 in that many groups. So I'm going to bring my 2 over, x to the 2, x to the 2, and x to the 1, right? So I broke up x to the 5. 5 divided by 2 is 2, and I have 1 remaining, like right here. What about 6? What if I divide 2 by 6? What do I get? Well, I got a flat, even number, right? So y to the 6. I could break this up into 6 divided by 2 is 3 with no remainder. So I could break it up into y to the 3, y to the 3. Well, would you look at that, right? So I have a group of 2 here, group of 2 here. Since the square root, they come out. So I have 6 x squared, y to the 3. And I can't break down 2 or x to the 1 anymore, so they're going to stay inside. So this is going to become 2x, and that is my final answer. All right. So if you want to take a second, pause the video, try to see what would be the cube root of 72 x to the 5 y to the 6. You want to take a second, pause, and I'll give you the answer, right? Okay, so if you're back here, so it's going to be 8 x to the 3, all right, y squared, and cube root. Sorry, let me move this a little neater. All right, cube root, all right, so I'm going to have remaining in here 9 x2. That will be your answer if we were taking the cube root of this, right? Remember, this is a new problem, right? So if you tried it yourself, this would be your answer in the bottom. Sorry, my mistake. This wouldn't be 8. That would be 2. All right, 2. 2x cubed, y squared, and you'd have the cube root of 9x squared. All right, let's move on. All right. Now let's do a quadratic linear system. All right. So I have y equals x squared minus 4x plus 3. And I have y equals 2x minus 2. Well, all right. So I don't really need to substitute much here, except I know what y equals, right? So I'm going to say y equal to y, right? I know y is going to equal to y, right? Obviously, right? Let me get a different color. Y equals to y, then I can set this y equal to this y. Then I can do x squared minus 4x plus 3 equals 2x minus 2. All right, there's a quadratic. I want to bring everything to one side, so I want to minus 2x plus 2, because I want this side to be 0, or minus 2x plus 2. This will cancel out. I'm going to get x squared minus 6x plus 5 equals 0. All right, so you could do it with the quadratic, or you could factor. I'm going to factor here because this one's really easy to factor. The factors of 5 that add up to negative 6. I know what that is, right? There's going to be x minus 5, x minus 1, right? Negative 5 times negative 1 is 5, and negative 5 plus negative 1 is negative 6, so this works out. So now my x's are 5 and 1, all right? I have my x's, but I want to find my y. So I'm going to plug these numbers into this equation that they give us right here, right? So I'm going to set 2x minus 2. And remember, quadratic linear systems, I want to find a set of coordinate or one coordinate that gives us the solution, which just means when the two equations intersect each other in the graph. So first I want to check x equals 1, right? So I want to say y equals 2x, plug in 1 here, minus 2, right? And I'm going to get, well, 2 times 1 is 2, minus 2 is 0, so it's going to be y equals 0. So my first set of coordinates will be 1, comma 0, parentheses. Now I'm going to check 5 right here, over here. I'm going to set y equals to 2 times 5 minus 2. 2 times 5 is 10 minus 2. So y is going to be 8. All right, so I'm going to get 5, comma 8. Those are the points of intersection. All right. All right. So that's how you do quadratic linear systems. If it's too complicated to factor, you don't feel comfortable factoring, you can always use the quadratic formula, which will always be provided to you during any exam and the regions, right? And the quadratic formula is, again, x equals minus b plus minus b squared minus 4ac over 2a, okay? All right. Now let's look at the radicals, right? Let's see how to solve the radicals, right? All right, so first thing, I want to get rid of the radical, right? What's bothering the radical? I'm going to rewrite the problem here, different color. 2x plus 7 square root of 2x plus 7 minus x equals 2. All right, I want this radical part by itself. All right, this part I want by itself. So when I square it, it'll go away. I'm going to add x to both sides. So I'm going to get 2x radical, square root of 2x plus 7 equals, it's going to cancel out, x plus 2. All right, so far so good. I just moved the x over to this side. Now I'm going to square both sides. When I square a square root, the square and the square root, they're inverse operations. They cancel out, right? They cancel out. They cancel out. So I'm just going to have 2x plus 7 on this side equals x plus 2 squared. X plus 2 squared is x plus 2 times x plus 2. All right? I'm not just going to distribute the two power 2 inside and call it x squared plus 4, right? That's not it, right? This means x plus 2 times x plus 2. All right? All right, so let's hash this out. Okay. So I'm going to get x squared plus 4x plus 4. And we're at 2x plus 7. All right. This is a quadratic. I have a square, x squared. So I'm going to set it equal to 0. All right. Minus 2x minus 7 on both sides. Minus 2x minus 7. All right. Just going to cancel out. I'm going to get 0 equals x squared plus 2x minus 3. All right. Okay. So now I'm going to rewrite this over here. X squared plus 2x minus 3 equals 0. Well, I could quadratic to solve for x, but I'm going to factor again because I remember my times table. The factors of 2 that add up to negative 3. I'm sorry, the factors of negative 3 that add up to 2, right? And that's going to be easy. That's going to be x minus 3. X plus 3 and x minus 1 will be 0. All right? Because 3 times negative 1 is negative 3, but 3 plus negative 1 is 2. So this works out. So my x values are going to be negative 3 and 1. Those are my solutions. The solutions are the opposite of what's inside the factors. All right, so now, remember, I have to check. When I solve radicals, I have to check. I have to plug these numbers back in to check to see if my equation is going to be correct. So first I'm going to check negative 3. I'm going to check negative 3 in the original equation. Right? So I'm going to have negative 3, 2 times negative 3 plus 7 square root minus negative 3 equals 2. I'm going to see if that works out. So 2 times negative 3 is negative 6. Negative 6 plus 7 minus negative 3 is plus 3 equals 2. Alright, so, I mean, it's going to be automatically false, right? Because we can't have a negative in the square root. Well, we could, but then we'll get an I, and I is not part of this equation. But let's work it out anyway. Negative 6 plus 7 is square root of 1. I don't know what happened there. Square root of 1 plus 3 equals 2. This does not work. Square root of 1 is just 1. Plus 3 equals 4. So negative 3 is extraneous. It's not going to work. All right? It's just not going to work. All right? Now I have to check 1. All right, now I have to check 1. I have to check 1 right now. So that's what I'm going to do. Square root 2. I don't know why that's happening. 2 times 1 plus 7 minus 1. Is that going to equal 2? So 2 plus 1. 2 times 1 is 2 plus 7. So 2 plus 7 is 9. So square root of 9 minus 1, is that going to equal 2? Is 3 minus 1, does that equal 2? Yes, it does, so that works. So my only solution here is going to be x equals 1. Right? I have to discard this negative 3 because it's extraneous. Right? It's very tedious, but these are all the steps we always have to do when we solve radicals. All right. Okay. So let's take a look at some factoring and some interest problems. All right. So blast from the past, factoring 10x squared minus 25x minus 125. All right. So first things first, right? If it asks you to fold a factor, you got to do a couple of things. Give me a second. All right. So first thing I'm going to do 10, does this term, 10x squared minus 25x minus 120, do any of them have anything in common, anything that multiplies into all of them, right? We know it's not going to be x because there's no x next to the 125. But I know 5 goes into all of them. So I'm going to, take out a 5, right? I'm going to factor out a 5. What does that mean? I'm going to divide each term by 5. Divide each term by 5, and I'm going to take it outside. So I'm going to have 5, 2x squared, 10 divided by 5 is 2, 25 divided by 5 is 5, 5x, 120 divided by 5 is 25. All right. Okay, now, remember, we have to look at the factors. All right, remember, we have to do A times C. A times C, right? What's A times C? My A here is 2. 2 times negative 25. Negative 25 is going to give me negative 50. So I'm going to have to look at factors of negative 50 that add up to negative 5, right? So I'm going to have to look A plus C equals B. So I want something, factors of negative 50 that are going to add up to -5, right? So there's only a couple. All right, so let's try uh, -50 plus 1. That's not going to work. Let's try -10 plus 5. Well, that's going to work. That's -5. My b here is -5. So that's going to work. Lucky us. We got it on the second try. So once you have all that, now this is what you do. Now we're going to break up this middle term, my b term, right? My b term is -5, right? I'm going to break up my b term into just like this, all right? Because this is -5x. So I'm going to break it up into -10x, right? Plus 5x minus 25. Think about it logically, right? This is true. -10x plus 5x is -5x. So we didn't really change anything, right? Nothing changed. We just did some math manipulation, all right? Now what we're gonna do is we're gonna factor out the common factors between these two terms first. So we're gonna have 5. I'm gonna factor out. So what goes into 2x squared and minus 10x? Well, 2 goes into 2 and -10. And they both have an x, right? X squared and x. So I can factor out 2x. So just going to 2x. All I have remaining is x minus 5. All right? Over here, what do 5x and -25 have in common, right? What can I factor out? Well, they have what in common? They have 5 in common, right? So I can take out a 5, right? If I divide 5x by 5, right? So I'm going to get 5, and I'm just going to have x remaining here, and then -25 divided by 5 is going to be -5. All right, so I see these insides match, so I'm on the right track, right? These factors match here. So now I'm just going to rearrange, right? It's up to you what you do. I like putting in the outside factors first. 2x plus 5. I'm rearranging 2x plus 5. And then I'm rearranging x minus 5. X minus 5. All right, and it's fully factored. That's it. That's my answer. All right, that's my answer. So again, see what common factors they all have. Factor it out, and then just keep factoring. And then after you do that, you do a times c, 2 times -25, -50, and then you see the factors of a and c that add up to b. My b here is -5, right? So I was finding -50 plus 1, -10 plus 5 equals -5. And then I break up my b term into these factors I found here. And then I factor out. Okay. All right. Now, let's get started, right? This is a interest problem. Just going to write the interest formula right here, right? A equals P 1 plus R over N and T. These are just some interest problems. Obviously, you might be given the final amount, or you'll have to find the principal, or vice versa, and that type of stuff is in your homework. Well, let's just go over this, all right? If you deposit $670 in an account, paying 4.2% annual interest compounded monthly, how much money will be in the account after 18 years? Right? So they give you the starting amount. So your P is 670. All right. What's your rate? Your interest rate is 4.2%. What's 4.2% as a decimal? Well, let's do some math here. 4.2% divided by 100%. I'm going to get 0.042. So my rate is going to be 0.042, right? Compounded how much? Compounded monthly. So that means monthly means how many times it happens per year, right? So there's 12 months in a year. So my n equals 12, all right? And the amount of time is 18 years. So t is 18, right? So I want to plug in all these values into this equation right here, right? This equation right here. All right, so let's take our calculator and let's do it. So let's put in 670 parentheses alpha y equals n slash t. Oops. Oops. 671 plus alpha y equals n slash t. My rate is 4.2%, so as a decimal that's 0.042. Compounded monthly, all right? Parentheses to the power of n times t, right? N is how much is compounded, so 12. And how many years? T, 18 years. Let's see what I get. So I get $1,425.04. All right. So let's go back. Let me look at that again. 1425004. So my final one is, if you're on the Regents or something, or on your test, I would recommend writing this down. A equals 670, 1 plus 0.042 over 12, 12 times 18. I say to write this down because just in case you put in the calculator wrong and you're in a rush or something, you got to finish up the question. If the grader sees that, hey, they know how to put in the formula, but they just made a simple error, you get partial credit, right, for, doing it like this, right? So instead of getting no points, you might get 1 point out of 2 points. So we got A equals 1,425.04. All right. So I put in this part right here, almost same question, but there's a difference here. If you deposit 670 into an account paying 4.2% compounded continuously, how much money will be in the account after 18 years? So this is very key, right? Compounded continuously. Remember, if you're compounding continuously, we have to use that special number we learned about again, right? We have to use this number E here, right? Because E compounds the interest or the growth rate at, the smallest, tiniest fraction of a second, right? It's not compounded monthly, daily. It's compounded at an infinitely small level. All right. So general formula is A equals P e to the RT, right? And this is the same as if you see y equals A e to the RX, right? It's the same one. So for interest, you have P, but for other problems, you'll have A. And they both mean the same thing, initial value. You have X here, and time, same thing. And R here, rate, right? That's the only thing it kind of stays the same along with the. All right, so let's put that in, right? Let's plug in all our values. We have all our values from before. So A equals P, which is 670. E to the R, which is 0.042, all right? And time is 18. All right, so let's put that into the calculator. So 670, all right? Second, right next to this 4 here, e to the x, 0.042 multiplied by 18 years. Enter. Oh, look, $14.26 cents. Sorry, $1,426.93, right? So big, huge improvements by compounding continuously, right? You're getting an extra whole $1.50. So our answer here is A equals 142693, right? Look at the difference, right? It's cash money right here. All right. If you watched the video, thank you for paying attention. If you have any questions, message me on Jupiter. Make sure you're ready for the quiz. It'll be given either Monday or Tuesday. Best of luck, and hope you all have a happy break.